Um, Hello, this is going to be a lecture on derivatives of constants, and it's going to be pretty short, but I want to make something clear that I did not make clear before. So, if you have a constant function, that basically means y equals c, right? There's no variable here. So, c can be anything. We'll take y equals, 2. So this is x, this is y. If y equals 2, that means for all x, you have this constant function at y equals 2. It's just a straight line. Sorry, I'll make that bigger. Alright. So, you can do this for any amount of, lines you want. You can draw them all in forever. You wouldn't do that, you get really tired after like 2 seconds. These are supposed to be straight. I'm sorry that I can't draw good. Or, well, I can't draw well. Anyway, so, what's the general form of a function? It's y equals ax plus b, right? That's a linear line. That's a basic function. I mean, you can also have any number of powers here, and you can also have any number of variables. So, like, we'll stick to one variable right now. Anyway, still single variable stuff. Anyway, so yeah. So this is basically the form. Okay, now if y equals a x to the 0 plus b, then, and we'll say a equals 1. And it doesn't really matter if it is or not, but we'll say that a equals 1. Then we get just b, right, which is some constant. So that's how we get a straight line that goes across horizontally. So its slope, remember, is denoted by this a component. And that's basically what the derivative is. It's the slope of a line or a function. So for linear equations, you have like ax, b. The derivative is always going to be y prime or f of x prime, because y equals f of x. So you can say either one, really. Y equal f. So y prime is just a. But if a doesn't exist, or if there's no x initially, then you're going to have something like this. Well, y is going to equal, b, we'll say, and y prime, well, there's nothing over here, so when you differentiate a constant, you get 1. No, I'm sorry, you get 0. You get 0. So the slope of that function is just, it's constant forever. There's no slope to it. And that's how this idea of constant derivatives of constant comes from. So, we'll go through an example. So let's say we have x squared plus 7. Well, y prime is going to be 2x plus 0, right? So we differentiate this term, and when we're adding functions, we differentiate them term by term. And you can always think of it in terms of variables. It's like there's like an x to the 0 here, sort of. And that's how you sort of group functions together when you're doing addition, right? So if you're adding two components, x squared as a component and then 7 as a component, then you get, well, the derivative of x squared, we know, is just 2x from so much previous work. I've done it like 3 times now, so you should know this. And the derivative of a constant, or an integer, or any number, that you can find, it's always going to be 0. Like the derivative of pi. If y equals pi, then y prime is equal to 0. It doesn't matter. If you just have y equals e, then y prime is equal to 0, because e is a number. If you have an x here, then this is not true. Then these are not equivalent, as it were. Not that these really would be equivalent anyway, but assuming that you just have e, then its derivative is 0. So I hope that clarified a couple things that I did in other lectures. Alright.